Human beings have a fairly simple relationship with geography. If a mountain is in the way, we drill through it. If a river is in the way, we build over it. And if an entire city is in the way, we usually move the city and try not to bring it up again. This habit has become extremely expensive. To understand how expensive, imagine spending $1 million every single day. You could buy a mansion on Monday, a private jet on Tuesday, and by Wednesday, start making the sort of purchases that require you to be removed from several government watch lists. But even if you kept spending at that rate far more than 1,000 years, you still wouldn't have enough money to pay for the most expensive project in this story. We'll get there, but first, we need a river. In the 1970s, Brazil and Paraguay looked at the Parana River and saw an enormous amount of water traveling past them for free. This was clearly unacceptable, so they spent roughly $18 billion building the Itaipu Dam and forced the river to get a job. It worked almost too well. The dam produced so much electricity that tiny Paraguay couldn't use all of its share and began selling the excess to Brazil. Paraguay had effectively become the friend who orders a giant pizza, eats 2 slices, and then charges everybody else for their leftovers. Itaipu was one of the largest construction projects ever attempted, but once humanity had proved it could redirect a river for $18 billion, burying a road should have been easy. Boston had a highway running directly through the middle of the city. It was noisy, ugly, and permanently congested, which made it a highway. The solution was obvious: take the entire road and put it underground. The project became known as the Big Dig, although the enormous financial hole might have prepared taxpayers slightly better. Engineers had to build tunnels beneath an active city without knocking down the city above them. By the time the bills, borrowing, and interest were counted, the Big Dig was expected to cost more than $24 billion. Boston finally got its road underground, along with a significant portion of Massachusetts' future income. Boston had land but didn't want to see its infrastructure. Japan had the complete opposite problem. Osaka desperately needed a new airport, but nobody wanted jumbo jets passing over their house at 3 in the morning, and there wasn't enough empty land nearby to build one. Japan responded to the shortage of land by building more Japan. Engineers dumped millions of tons of material into Osaka Bay, created an artificial island, and placed Kansai International Airport on top of it. Depending on what is included, the airport and its islands cost somewhere between $20 billion and $40 billion. There was only one small issue. The island began sinking. To be fair, the engineers knew it would sink. They simply hoped it would do so politely. Instead, parts of the island settled much faster than expected, meaning the terminal had to be repeatedly adjusted to remain level. Japan had built a $40 billion airport in the sea and then spent decades negotiating with the sea about where exactly the airport should stay. Japan created new land, China went in the other direction. China wanted more electricity from the Yangtze River, but several cities, towns, and more than 1 million residents were inconveniently located where the reservoir needed to be. So the residents were relocated, the settlements disappeared beneath the water, and the Three Gorges Dam rose in their place. The final cost reached roughly $35 billion, including the dam, electricity network, and the relocation of around 1.4 million people. It became the largest hydroelectric power station on Earth and one of the clearest demonstrations of an important engineering principle. Almost anything is possible when the government owns the land, controls the budget, and doesn't particularly need everyone to agree. Dams are an excellent way of producing electricity, provided you happen to have a gigantic river nearby. Britain did not, so it decided to produce electricity by splitting atoms instead. Hinkley Point C began as a plan to build 2 nuclear reactors in Somerset. Nuclear power stations are essentially very expensive kettles, except the heating element contains uranium and the instruction manual is several million pages long. The project was originally expected to cost £18 billion. Its current estimate is around £35 billion, and the first reactor is now expected years later than originally planned. This is not necessarily unusual for a nuclear project. When every pipe, bolt, and weld must be safe enough to sit beside an artificial atomic reaction for 60 years, the phrase "that will probably be fine" tends to create additional paperwork. Britain then decided that producing expensive electricity was not enough. It also needed an extremely expensive train on which to use it. HS2 was supposed to connect London with northern English cities at high speed. The northern sections were later cancelled, leaving a considerably shorter railway with a remarkably persistent budget. The remaining program is now estimated to cost between £88 billion and £103 billion. At some point, the train stopped being the fastest moving part of HS2. That honor went to the price. Across the Atlantic, California had been working on the same idea: connect San Francisco and Los Angeles with high-speed rail. On a map, this looks easy. You draw one line down the state, write train beside it, and wait for the complements. Unfortunately, the real California contains mountains, cities, farmland, earthquake zones, property owners, and lawyers. Especially lawyers. The latest estimate places the railway's total cost at approximately $126 billion. By the time it is finished, passengers may be able to travel between San Francisco and Los Angeles faster than it took California to decide how to build it. Once a railway starts costing more than $100 billion, you would think humanity might finally stop adding zeros. China did not. The Yarlung Tsangpo River cuts through the Himalayas before becoming the Brahmaputra downstream. At one point, the river dropped so dramatically that engineers looked at it and saw what may be the largest untapped source of hydropower on Earth. China has now begun an estimated $170 billion project involving 5 hydropower stations. It is being built in a remote, mountainous, and earthquake-prone region where even getting the construction equipment to the site is its own construction project. China built one of the most expensive dams in history, waited a few years, and then apparently decided it had been thinking too small. But even a $170 billion dam doesn't come close to the largest construction program in this story. In 1956, the United States committed itself to building a vast network of interstate highways, tens of thousands of miles of roads, bridges, exits, and interchanges spread across the country, connecting cities that had previously been separated by days of difficult travel. In modern money, the interstate highway system cost roughly $500 billion. And what did America receive for $500 billion? Roads. Not a floating city, not an artificial sun, not a machine in space, just an enormous collection of gray strips that millions of people now use every day while complaining about the traffic. The highway system may have cost the most overall, but it was built across an entire continent over several decades. The most expensive single object humanity has ever constructed is much farther away, about 250 miles above your head. The International Space Station cost approximately $150 billion, but unlike every other project in this story, it simply couldn't be built in one place. Its parts were manufactured in different countries, placed inside rockets, fired into space, and assembled while orbiting Earth at thousands of miles per hour. Imagine having your furniture delivered one cupboard at a time over several years, except every delivery costs hundreds of millions of dollars and a missing screw falls around the planet forever. Hundreds of thousands of people helped build a laboratory in an empty void that would kill a human being in seconds. Nations that had spent decades pointing missiles at one another somehow managed to make thousands of separate parts fit together perfectly in space. And after spending $150 billion to escape the planet, the astronauts arrived, looked back down at Earth, and discovered something remarkable. From up there, none of our borders are visible.